Okay, let's look at example 2.4. Okay, in this example, you have a car being unloaded from a boat or ship, whatever you call it, and a person pulling on this rope to move the car just a little bit, and it produces an angle. So we are supposed to find out what is the tension in this here rope. Okay, so how do we do this? Well, let's start with a free body diagram. Where do we want to consider the free body diagram? We can consider here. There's lots of places that you can do it. The one that's going to make the most sense is point A. So let's look at point A. What do you have at point A? You have 3,500 pounds coming down. You have a tension, we'll call it TAC, and that's coming off at 30 degrees, right? Oh, sorry. And you have a force coming up off here. I'm drawing this a little bit exaggerated. Actually, quite frankly, it's a lot exaggerated. But just so we can show this is 2 degrees, and this is TAB. Okay, so how do we do this? Okay, now we have all our forces defined. Let's go through and let's do sum of the forces in X is sum of the forces in Y is equal to 0, right? So let's start with X. What do we have in X? Well, we have our TAB. Now the X component of that is what? It's going to be times sine of 2, and that's going to be to the left, and so I could put a negative sign on it plus this other one, but I'm just going to say the left force is equal to the right forces. So this is going to be TAC times cosine of 30. So that is our first equation. And then we're going to take the sum of the forces in y equals 0, and that's going to tell us what? TAB, in this case, is going to be cosine of 2 degrees. That's our up, and that needs to equal our down forces, which are going to be 3,500 plus TAC times sine of 30. So this is equation 2. Okay, so now we simply have two equations, two unknowns. What are our unknowns? It's TAB and TAC. And so we just solve for it. The way I did it, I took this first equation right here, and I solved for this in terms of TAB. So let's just do that because I can follow my notes. TAB is equal to TAC times cosine of 30 over sine of 2. Okay, and I can plug that into this right there. And so you end up with TAC cosine of 30 over sine of 2 times cosine of 2 is equal to 3,500 plus TAC sine of 30. And so now that's just one equation and one unknown, and you find that TAC is equal to 144 pounds. Now, I think that's all technically that's being asked for, but we might as well figure out the TAB as well. So let's go through and plug that back into that equation, and you end up with TAB is equal to 3,574.2 pounds. Okay, so what do we have? We are claiming that this person is pulling with 144 pounds to the right, down and to the right, and that the tension in this cable is 3,574. So let's do a little bit of a smell check, sanity check. Does this smell right? Does it pass the sniff test? Okay, 3,574 pounds in this one right here. Well, is it okay that it's more than the weight of the car? So you have the car pushing down here with 3,500. So if it is anything less than the car, then that should cause you a little bit of heartache, because otherwise this thing is going to be moving, right? There's no way to overcome that. Now, the question is it okay for it to be more than the 3,500 pounds? Well, you got two things going. A, you have this person over here, had a portion of this rope here is pulling down. So you're adding a little bit to it there, and by pulling at the angle, it's going to increase that tension. So therefore, 3,574 seems reasonable. Now, as far as a person, 144 pounds, does that pass the smell test? That's pulling pretty hard, but this doesn't seem totally unreasonable either. So this thing seems to pass the test, and it looks like it's the right answer.